All right, today we're tackling one of the wildest, most reliable events in our entire solar system, the sun's absolutely incredible 11-year magnetic flip. Yup, you heard that right. Like clockwork, our star completely reverses its magnetic polarity. The whole global field just flips upside down. It's this huge cosmic reset button, and for decades, nobody could quite figure out how it happened. That's the big question, right? How does a giant ball of plasma pull off a trick like this? For the longest time, the best guess was that the answer was buried deep inside the sun's fiery core. But here's the kicker. It turns out the answer wasn't deep inside at all. It was right there, hiding in plain sight. Okay, so to crack this case, first we need to get a handle on what's going on under the hood. We need to understand the sun's magnetic engine. So picture this. The sun really has two main magnetic fields working together. You've got the poloidal field, which runs north to south, kind of like the lines of longitude on a globe. And then you have the toroidal field, which wraps around the sun east to west, almost like a bunch of rubber bands. The whole 11-year cycle is basically these two fields turning into each other. And this whole transformation process, we call that the solar dynamo. Think of it like a giant cosmic engine that takes the motion of all that swirling plasma and turns it into magnetic energy. Now, the first part is pretty well understood. The sun's rotation grabs that north-south field and stretches it out, creating the east-west one. No problem there. But here's the part that had scientists scratching their heads for ages. How does that powerful, wrapped-up east-west field get turned back into the north-south one to complete the flip? You see, without that step, the whole cycle just grinds to a halt. It was the crucial missing link. So for years, the prime suspect in this mystery was a process that, get this, nobody had ever actually seen. It was called the alpha effect. The theory went that deep inside the sun, the crazy churning of the plasma would twist and contort that east-west magnetic field, forcing it to pop back out in a north-south direction. It's a neat idea, but the whole thing was supposedly happening way down deep, completely hidden from view. And look, this wasn't just some tiny detail. As the authors of the paper we're looking at today put it, figuring this out was a major outstanding problem in solar physics. The entire theory of the solar cycle was hanging on this one invisible mechanism. So for decades, the alpha effect was the leading theory, but it was really just a black box, a ghost in the machine. Scientists were confident that something was closing the loop. They just couldn't prove what it was or where it was happening. But then, everything changed. New data allowed scientists to look at the whole problem from a totally new angle, by pretty much ignoring the deep interior and focusing on clues that were popping up right on the surface. And the key to this whole breakthrough was NASA's Solar Dynamics Observatory, or SDO. This satellite gave us these unbelievably detailed, high-res maps of the sun's surface magnetism. It let researchers literally watch magnetic regions as they were being born. Okay, check this out. What you're seeing here is a magnetic active region, what we usually call a sunspot group, just starting to poke through the sun's surface. That little disturbance is where our story starts. Now, fast forward about a day. You can see the region has gotten way bigger as that magnetic field keeps pushing its way out from below. The two polarities, the black and white spots, they're becoming much more distinct. And after about 2 days, bam, we've got a fully formed magnetic bipole. You can see the two opposite polarities, one negative, one positive, totally separated on the surface. But, and this is the really important part, look closely. They aren't perfectly aligned east to west. There's a slight tilt. And that consistent tilt? That's the crucial clue. It's an observed rule called Joy's law, and it basically says that these sunspot pairs always emerge with this slight, predictable tilt, where the leading spot is always a little bit closer to the sun's equator. So here's the big aha moment. This systematic tilting is exactly what you need to take an east-west magnetic field and create a new north-south one. The tilt is the answer. And just like that, the mystery shifts. It's no longer what's happening deep inside the sun, but what is causing this tilt right here on the surface. And the answer, it turns out, was far simpler and, frankly, far more elegant than anyone had imagined. Just stop and think about that. What kind of force could possibly be powerful enough and consistent enough to grab these gigantic magnetic regions, each one is many times the size of Earth, by the way, and systematically tilt them in the same way, over and over again?
And this chart right here, this is the smoking gun. The bar on the left shows the amount of tilt scientists actually observed in the sunspots. The bar on the right shows how much tilt you'd expect only from the plasma flows on the sun's surface. It's a near-perfect match. Case closed. The culprit wasn't some deep, mysterious force at all. It was the observable, measurable flows of plasma right on the solar surface. The magnetic fields emerge mostly flat, and then these surface currents, influenced by the sun's rotation, literally drag the two poles into their tilted position. The mystery was solved on the surface, not in the depths.
So this discovery completely replaces a decades-old theory with a new, observable mechanism. So let's break down how this new mechanism, which they're calling the delta effect, actually works. First, an updraft pushes a loop of that magnetic field up through the surface. Second, as it emerges, horizontal plasma flows push the two ends apart. And third, this is the magic. The sun's rotation, the Coriolis force, acts on that separating motion, twisting it and creating that systematic tilt. It's a beautiful, direct physical process we can actually see.
So let's just put them side by side. The old alpha effect was theoretical, hidden, and was thought to generate a whole new field deep inside the sun. But the new, evidence-based delta effect, it happens right on the surface. We can see it with our satellites. And it doesn't need to create a new field. It just rearranges the existing one, using those plasma flows to create the tilt that makes the whole cycle work.
And that just leaves us with a pretty cool thought. For decades, a major solar mystery was thought to be unsolvable because the cause was hidden. But the answer was right there on the surface the whole time, just waiting for the right data and a fresh perspective. It makes you wonder, what other huge cosmic mysteries are hiding out there in plain sight?